We continue with reduction of aldehydes and ketones. Next is reduction of aldehydes and ketones into alcohols. Reduction of aldehydes and ketones into alcohols. Last class we have discussed the reduction of aldehydes and ketones into alkanes. That means there are two types of reaction: Clemmensen reduction and Wolff-Christian reduction. Here we are discussing the reduction of aldehydes and ketones into alcohols. As you know, we know that primary alcohol on oxidation will give aldehyde. Primary alcohols on oxidation will give aldehyde. That means aldehydes on reduction will give primary alcohols and ketones on reduction will give secondary alcohols. Okay, so first one is reduction, catalytic reduction. First one is catalytic reduction. Catalytic reduction. That means reduction of with hydrogen. Reduction with hydrogen in presence of nickel or platinum or palladium. Okay, then example, acetaldehyde, CH3, C double bond OH. Okay, when reduced with hydrogen in presence of nickel, anything, nickel, platinum or palladium. Okay, what will happen? The CO group will be reduced to CHOH. So in alcohol, that means here what is happening? The CO group is converting to CHOH. This is happening. CO group is reduced to CHOH. So what we get here? CH3, CHOH, CH and H. What is that? CH2OH. Okay. And if you take a ketone, CH3, C double bond O CH3 acetone, when reduced with hydrogen in presence of nickel, platinum or palladium, what do we get? CO group is reduced to CHOH. What do we get? CH3, CHOH, CH3. So here you are getting primary alcohol, and here you are getting secondary alcohol. That means aldehyde on reduction will give primary alcohol, or you can say the primary alcohol on oxidation will change into aldehyde. Secondary alcohol on oxidation will change into a ketone, or you can see that ketones on reduction will change into a secondary alcohol. Another example, if we take one more example, okay. If you take acetaldehyde, so if you take benzaldehyde, what we get? Okay, see double bond OH, what we get on reduction with the hydrogen in presence of nickel, CHOH. That means here it is CHOH. That means ring CH and H. What will happen? CH2OH. We get benzyl alcohol. What do we get? Benzyl alcohol. Okay, so this is the first one, catalytic reduction. Now, second one. Second reduction. Reduction with second one. Reduction with metal hydride. Okay, that means metal hydride. That means reduction of aldehydes and ketones with lithium aluminium hydride, metal hydride, lithium aluminium hydride, sodium borohydride, etc. So again, CH3, CHO, C double bond OH, CH3, CHO. When reduced with lithium aluminium hydride, LiAlH4. This is a metal hydride in presence of tetrahydrofurans, THF. Okay, followed by H3O plus. Again, what we get? Acetaldehyde, 2-carbon aldehyde will be converted to aldehyde, is converting to the same number of alcohol containing same number of carbon atoms. So CH3 CHO is reduced to CH3 CH2OH. So we get CH3 CH2OH, CH3 CH2OH. Or another reducing agent is what is that? Same, instead of lithium aluminium hydride, you can use sodium borohydride, NaBH4, sodium borohydride in presence of methanol, CH3OH, followed by hydrolysis, H3O plus. What do we get? Again, same thing. CHCO group is converted to CH OH, CH, CH2. So what we get? CH3, CH2, OH, ethanol. We get ethanol. We get ethanol. And another example, so keep it in mind, the second one is reduction with metal hydride. There is no change. What is happening? Aldehyde is converting to primary alcohol, and if you take a ketone will change into a secondary alcohol. Okay, another example, look at it here. We take, look at it here, we take a ketone, okay, double bond O, okay, here it is, this is a ketone, okay, what is the name of this ketone? Suppose there is no double bond, this is cycloheptanone, so here is a double bond, that means, what is the number of carbon atoms in the ring? 1, 2, 3, 4, 5, 6, 7. So what is this one? Cyclo. Since there is a double bond, that is hepti, since this is a ketone, heptinone, E-O-N-E, heptinone, heptinone, okay, that means there is a double bond. Now you can look at it here, 1, 2, 3, 4, the double bond is at the fourth carbon, so what is the actual name? Hept4-enone, okay, so actual name is Hept4-enone, okay, the compound name is cyclohept4-enone, okay, that means the double bond is at the fourth position, that is why cyclohept, hept4-enone, okay, cycloheptanone 4-enone reduced with, so first we are reducing with LiAlH4, or you can use NaBH4, of course THF4 methanol is there, followed by H3O plus, what we get, we know that the CO group is converting to CHOH, CO group is changing to CHOH, and what we get, we get a structure like this, we get, okay, here it is a double bond, okay, and here it will become C, here is H, OH, this is understood, this, here it is H, okay, that is understood, no need to show, okay, we get this structure, Now, the same compound, so look at it here, first case is lithium aluminum hydride and NaBH4, we are only the CO group is reduced to CHOH, and we get, now suppose the same compound is reduced with hydrogen in presence of nickel, okay, that means catalytic reduction, suppose this is undergoing catalytic reduction, that means reduction with the hydrogen in presence of nickel, what will happen, or what is the compound we are getting? Look at it here, we get a structure like this, okay, here it is OH, and what is happening here, hydrogen in presence of nickel will reduce the CO group, carbonyl group, CO group is changing to CHOH in the case of the previous case, and you can see that if we use hydrogen in presence of nickel, that will reduce the double bond also. So what will happen? This will change into CH2. So what is that? The double bond is broken, and one hydrogen is coming, and one hydrogen is here also, and we get cycloheptanol. What do we get? Cycloheptanol. Okay, so there is the double bond is also reduced. That we have studied. If you take ethene, CH2 double bond CH2 reduced with the hydrogen in presence of nickel, what will get? Ethane, CH3 single bond CH3. That is happening. The same thing is happening here also. This double bond is also reducing if we use hydrogen in presence of nickel. But if you use LiAlH4 or NaBH4, it won't reduce the double bond or triple bond. It will reduce only the carbonyl group. CO group will be converted to CHOH. That is a very important point. So keep it in mind. And next is another point you have to remember in this case. Same thing only. If a double bond or triple bond is in conjugation with CO group, LiAlH4 will reduce the double bond or triple bond, but NaBH4 not, H4 not. What is the meaning of that? When a double bond or triple bond is in conjugation with the CO group. Okay, so first we write an example. Look at here, CH3, CH, double bond CH, single bond C, double bond or H. Okay, now this is in conjugation. So double bond, single bond, again CO group. Oh, okay, this double bond is in conjugation with the CO group. Okay, look at here, what do you mean by conjugation? Here is double bond, here is single bond, here is double bond. So these two are in conjugation, this double bond and this double bond. In conjugation, what is happening? If we reduce with the LiAlH4, if you use LiAlH4, okay, and H3O plus, what will happen? We'll reduce the double bond or triple bond. So what we are getting? If you use LiAlH4, we get CH3. This will also be reduced. So what will get? CH2, single bond CH2, and here it will become CHOH. That means H and H, CH2OH. You get this compound. That means butanol. You are getting both the double bond and the CO group. Both are reduced. When the double bond is in conjugation with the CO group, if you use LiAlH4, what will happen? Both the double bond or triple bond and the CO group both will be reduced, and what we get here, CH3, this will be reduced to CH2, CO group is converted to CHOH, that means CH2OH. Now the same compound, if you take the same compound and if you are reducing with NaBH4, sodium borohydride, H3O plus, what will happen? It won't reduce the double bond present in the double bond or triple bond present in the compound. Okay, and it will reduce only the CO group. So here you are getting CH3, CH, double bond CH, only the CHO group will be converted to CH2OH. CHO group will be converted to CH2OH. Okay, this point also you have to remember. So keep it in mind when a double bond or triple bond is in conjugation with the CO group, LiAlH4 with the aluminum hydride will reduce the double bond as well as the CO group, but NaBH4 will reduce only the CO group, the CHO or the CO group will be reduced to CH2OH. Clear? Okay, one more example if you want to be, we can take, okay, one more example, look at it here. Double bond is in conjugation with, so you take, suppose you take this compound, CH, double bond CH, single bond C, double bond O, H. Okay, this is the compound. So what we get, if you take LiAlH4, what we get? We get, okay, look at it here. CH will be converted to CH2, single bond CH2, and here it will become CHOH and H, and what will be CH2OH. Okay, and if you take NaBH4, what we get? We get here. Okay, here it is like this. This double bond won't be affected, so only the CHO group will be converted to CH2OH. So keep it in mind. Okay. Now next third one. So first one is catalytic reduction. Second one is reduction with metal hydrides like lithium aluminum hydride or sodium borohydride, and the last one is third one, reduction using aluminium isopropoxide, aluminium isopropoxide in presence of isopropyl alcohol, in presence of isopropyl alcohol. This reduction is known as MPV reduction. That means Merwin Kondorf Verley reduction. Merwin-Pondorf Verley reduction, which is known as a MPV reduction. Okay, MPV reduction. Reduction using aluminium isopropoxide in presence of isopropyl alcohol. Reduction of aldehydes and ketones using aluminium isopropoxide in presence of isopropyl alcohol. This reduction is known as Merwin-Pondorf Verley reduction. Merwin-Pondorf Verley reduction, or which is known as a MPV reduction. Look at it here. So we take aldehyde CH3, C double bond H aldehyde is reduced with aluminium isopropoxide in presence of isopropyl alcohol. First I am writing isopropyl alcohol CH3, CHOH, CH3. This is isopropyl alcohol or propan 2-ol, which is also known as isopropyl alcohol. Aluminium isopropoxide. How do you write aluminium isopropoxide? AL O CH CH3 CH3 thrice. Okay. Al OCH CH3 CH3 size aluminium isopropoxide. Actually, this is a reversible reaction. We get here you are getting CH3 CHO. 2 carbon aldehyde will be converted to 2 carbon alcohol. That means CH3 CH2 OH ethanol, and always your byproduct is acetone CH3 CO CH3 CO CH3. Okay. So, or in general, how will you write aldehyde when reduced with isopropyl CH3 CHOH isopropyl alcohol and aluminium isopropoxide Al OCH. How you can write Me twice thrice. That means what do you mean by Me twice? 2 methyl group CH3 also can be written as Me2. This thrice, but we get aldehyde will be converted to primary alcohol. Plus byproduct is acetone plus acetone. And if you take a ketone plus same thing, isopropyl alcohol CH3 CHOH CH3 in presence of aluminium isopropoxide, we get secondary alcohol plus acetone. And keep it in mind, this is a reversible reaction. And look at here, the forward reaction, this conversion of aldehyde or ketone into alcohol using aluminium isopropoxide and isopropyl alcohol. This reaction is known as MPV reduction, and the reversible reaction that we have studied, that is open-air oxidation. The reversible reaction is known as this reaction, conversion of alcohol into aldehyde or ketone using aluminium isopropoxide and isopropyl alcohol. This we have studied. Okay, that is known as open-air oxidation that we have studied. Okay, and if we take another example for MPV reduction, you can take any example for MPV reduction. Okay, look at it here. If you take acetophenone, okay, COCH3 acetophenone, okay, plus isopropyl alcohol CH3 CHOH CH3 in presence of aluminium isopropoxide ALOCH. You can write CH3 or you can write CH3 twice, and here it is thrice. Okay, CH3 twice, or you can write CH3 or you can write Me twice, or you can write CH3 twice. Then thrice, what we get? You get CO group will be converted to CHOH, and what we get? Look at here, we get secondary alcohol like this. Here it is CHOH. CO group will be CH3. You get CH3. So this type of reaction, this reaction is known as MPV reduction, and the reverse conversion of alcohol into aldehyde or ketone using aluminium isopropoxide and isopropyl alcohol, which is known as open-air oxidation. This we have studied, open-air oxidation. The reverse reaction is known as open-air oxidation. That's all about reduction of aldehydes and ketones. The next class we will discuss the oxidation of aldehydes and ketones, and thank you.